Welcome to Climate Now, a podcast that explores and explains the ideas, technologies, and the practical solutions that we'll need to address the global climate crisis and achieve a net zero future as quickly as possible. I'm James Lawler, and if you like this episode, please leave us a review wherever you listen to your podcasts, share this episode with your friends, or tell us what you think at contact@climatenow.com. We love to hear from our listeners. In today's episode, we're taking a look at what is known as renewable diesel, a fuel that is made from organic waste, like used cooking oil and agricultural byproducts. And we'll discuss how it can be used to mitigate hard-to-abate climate impacts of the trucking industry in particular. We'll speak with Matt Luke and Chris Cooper of Neste, one of the leading producers of renewable diesel and other biofuels across the globe, along with BJ Johnson of the company ClearFlame, a company working to retrofit diesel engines to allow them to run on a wide range of cleaner fuels. But first, let's get to our news segment, This Week in Climate News. This Week in Climate News, I'm joined by Julio Friedman. Julio, great to see you again.
Delighted to be here as always.
What's new this week?
Perhaps we should start with the State of the Union. Let me say that he highlighted the climate provisions in the Inflation Reduction Act rather strongly. And he talked about them again in his favorite context, jobs, 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 in terms of the possibilities of America, and that climate change is driving us to create new opportunities by looking at new sectors and new possible technologies. He talked about solar and heat pumps. He talked about wind. He talked about hydrogen. It was terrific to see that kind of highlight. We did not have that in prior State of the Unions. We did not have that even in the Obama administration, much less the Trump administration. So Biden is really putting forth a vision for America in which climate change and wealth creation work hand in hand to create opportunities.
And that's such an important message, I think. Among the effects of the IRA should be lower utility bills, creating more jobs. And I think 100,000 jobs have been created since the IRA passed last August, according to a recent analysis by the organization Climate Power. And certainly there should be a lot more coming.
Indeed. But in part because of who the president is, he really cares about kitchen table issues. And so he talked about the fact that cleaning the grid would actually make energy costs go down. And that's a message we can't say often enough.
Another interesting story this week that we saw was the latest development in the sort of slow march to what appears to be approval of a massive lithium mine in Nevada. This is the Thacker Pass lithium mine project that is being developed by Lithium Americas Corporation. And this project has been sort of in planning phases for many years. In the most recent ruling, the judge dismissed a variety of arguments made by the mine opponents, including concerns about groundwater aquifers and air quality. And really, the dismissal was not that, these things don't matter, but rather that a jurisdictional decision effectively that the Bureau of Land Management would, and their various regulations would prevent this mine from violating state water quality standards or other environmental standards. So these developments, while not a green light yet for this mine, which should produce roughly enough lithium every year for the manufacture of 1 million passenger vehicles, is probably a positive step towards an eventual approval.
So first of all, I sincerely hope this mine gets built. Not only should the United States carry some of the environmental burden for lithium production, which currently we don't, but also back to the IRA again, there are Made in America provisions. If we actually want to get the electric vehicles built, having a U.S. lithium mine will help get more deployment more quickly. I do not know if this decision will count as precedent or not, but we're going to need more than just lithium mines. We're going to need copper mines. We're going to need rare earth element mines. We are going to have to get these materials made in the United States. And in the State of the Union, the president talked about secure supply chains, that he doesn't ever want the U.S. to be vulnerable to supply chains from other countries. This is what that looks like. It is also what wartime footing looks like. People have asked for wartime footing for climate. That includes new lithium mines in places like Nevada. And so these kinds of conflicts and these kinds of questions are going to be part of the landscape for many, many years to come. Finally, there was a story I saw that looks like a preview of coming attractions in the United States. In Europe, they're having a hard time getting agreement across the European Union on what constitutes green hydrogen. And a few months ago, it looked like there was a breakthrough in which Germany would accept nuclear energy as one of the feeds for green hydrogen production. France has 70% of their power as nuclear, and so they were keen to see that happen. It seems like there's still friction in the European Commission around these kinds of questions, and Germany and France have been making objections of various kinds. And Spain as well. What happened this week was essentially a commissioner in charge of these things hastily withdrew a planned meeting. He said, you know what, we're not going to talk about this. And the response was, what do you mean we're not going to talk about this? But in point of fact, it gets at the heart of these kinds of challenges. Green hydrogen is not just a climate challenge for Europe. It is a way for them to reduce rapidly dependence on Russian gas in the wake of the war of Russian aggression against the Ukraine. Inability to reach consensus on what clean is actually hampering their national security as well as their economic development plans. But as people square off, is blue hydrogen clean or not? Is green hydrogen clean or not? Is nuclear allowed? Is hydro allowed? These sorts of things will diminish the pool of options, and they will definitely slow things down. If in the United States those become the target of future lawsuits, it'll slow things down even further.
Thanks, Leo. One more story just that caught our attention this week was a story that we saw about the Korea Gas Corporation, abbreviated KOGAS, has hired a technical advisory firm, DNV, to assess the viability of blending hydrogen into South Korea's transmission network for natural gas. South Korea has been taking a number of steps toward building a hydrogen economy in that country, including plans to create 6 hydrogen cities, each of those cities to receive about $40 billion over the next 4 years as they attempt to develop that infrastructure.
So U.S. infrastructure is pretty poorly configured for hydrogen blending. It's entirely likely that Korean infrastructure is much better. It is newer, they have different materials, it's managed differently. So they may be able to get quite a lot of blending because they do not have access to other kinds of renewable energy. Things like clean hydrogen are important for them in terms of domestic heating, industrial heat, all these kinds of things. I do think that their interest in blue hydrogen is noteworthy but misguided. There's not going to be a lot of places to store CO2 around Korea. It's just not geologically fit. So they're going to probably need more nuclear power if they really want to make a lot of hydrogen, which is itself a politically fraught issue in Korea.
Now for our interview segment. The main focus of our episode today is on renewable diesel. Is it really renewable? What is its emissions profile? How is it being used today? How much of it is there? We'll be going in and out of our conversations with Chris Cooper and Matt Luke from Neste and BJ Johnson of Clearflame to learn more about renewable diesel and other biofuels and their potential to help decarbonize industries like shipping, trucking, and aviation. Founded by BJ Johnson and Julie Bloomreiter in 2016, Clearflame is a company that is retrofitting diesel engines to expand the range of fuels they can run on, which could help shift the trucking industry away from traditional fossil fuels. Neste, on the other hand, was founded in 1948 as Finland's national oil company. Starting in the 1990s, Neste began to focus heavily on developing biofuels like renewable diesel, and today is one of the world's largest producers of this fuel. Chris Cooper is the president of Neste United States, and Matt Luke is the company's technical manager of renewable road transportation. First, we will cover some of the basics, such as what is renewable diesel, what differentiates diesel and gasoline, and what is the difference between renewable and biodiesel. Then we'll discuss some of the raw materials that go into renewable diesel and how these can be sourced in a sustainable way. Finally, we'll outline some of the developing markets for renewable diesel and other biofuels and how the fossil fuel industry is responding to the growing demand for renewable fuels. We start our conversation with Clearflame's BJ Johnson to learn some diesel basics.
Gasoline and diesel are fairly similar. They all come out of the same barrel of oil. So effectively, what you're doing is you're taking that barrel of oil and you run it through a distillation column. You separate it out by kind of how complex the molecules are. And so these are literally just coming out of different trays of a distillation column. The lighter molecules, things that have between 4 and 12 carbons, mostly around 8 carbons, tend to get pulled out in the gasoline tray. So it's lighter, slightly less lubricious, more aromatics, harder to ignite. Diesel is the slightly heavier, more oily version that comes a tray or two lower in the distillation columns, C12 to C20 or so.
I wonder if you could just give us sort of a primer on various replacement fuels for diesel. Let's just start with biodiesel. What is biodiesel and why is it biodiesel?
Yeah, so biodiesel is a diesel-like molecule that you make from a bio feedstock. So predominantly, it's going to be a lipid feedstock, a fatty, oily feedstock. In this country and in most the countries where it's used, that means it comes from soybeans. So you take the soybeans, you extract the oil from them, do some chemical processes that if I try to name, I'll butcher, but basically get it close enough so that it somewhat looks like diesel. It is not identical to diesel. It's actually one of the challenges with biodiesel. You really can only use it up to about the 20% level, so you blend it mostly into regular diesel. But it is the part of that you are using in a biological way, significantly lower in carbon than the petroleum base. Its challenges are soybeans are not the most feedstock producing crop. You don't get that much fuel energy per acre. And then, as I mentioned, you have to blend it with petroleum anyway. That's really its big challenge. That has led to the rise of something called renewable diesel, which honestly, biodiesel is renewable too, and it's probably just a different name because that's how marketing works. But it is also a different product on the end. Renewable diesel is actually molecularly identical to regular petroleum diesel. You can kind of think of it as if you were to take biodiesel and do a little bit extra kind of chemical work on it in terms of the synthesis to make it more identical to diesel, it'll make it more expensive, which it is. Mm-hmm. But it will also make it a direct drop-in replacement. So you can use renewable diesel directly as a substitute for regular petroleum diesel. The challenge with renewable diesel is it has all the same feedstock limitations as biodiesel. It's great if you can make it from animal fat. It's great if you can make it from waste oil. It's only okay if you're making it from soybeans, and it's bad if you're making it from like palm oil or something.
Right.
So you really got to be careful on the feedstocks, and it is a very process-intensive production. It is not cost competitive with regular diesel right now, and it's still very subsidy reliant.
Okay, so renewable diesel is a direct substitute for petroleum diesel. Why does your company, ClearFlame, focus on diesel as opposed to regular gasoline?
In the 50s and 60s, most of the trucks on the road in the US were gasoline trucks. But when fuel prices began to become a problem, the 15 to 20% more efficient that diesel engines are was 15 to 20% lower operating costs. In a matter of decades, the entire sector changed to be run by diesel. Same is true in agriculture, construction, mining, most other commercially oriented sectors. Most of the world's population lives in developing economies, and then the access to goods and electricity that diesel engines provide is actually critical to improving their quality of life and their standard of living. And we need to find a way to increase energy access in a way that is still fundamentally sustainable. And that became the thesis behind ClearFlame. How do we get a cost-effective, scalable, easy-to-adopt solution that can improve people's lives across the globe without compromising our environment?
So let's talk about what that technology is. So what exactly is ClearFlame?
ClearFlame is, you can think of it as a set of modifications that you can make to a diesel engine to make it fundamentally fuel agnostic. So when I was talking about making people's lives better with engines, that is a characteristic of the diesel engine design. There's a reason it dominates the applications it does. It's high torque and efficient and powerful and has rapid demand response. The negative associations with diesel engines are actually related to the petroleum diesel fuel that is used in it. And so ClearFlame's technology, we change about 10 to 15% of the parts of the engine. We've proved that you can do this as a retrofit. So we've retrofitted existing engines. We're working with one of our investors, John Deere, to make this a new OEM product too. But when you integrate the hardware and software changes of our system, you can run the diesel engine, you can deliver all of its economic value, but running on a decarbonized liquid fuel like an ethanol or methanol or even long-term ammonia, which is not only going to drive down your costs, which is important in these cost-conscious sectors, but also reduce emissions, and emissions broadly, not just the CO2 we were just talking about, the greenhouse gas, but also the criteria pollution, the soot and smog that kills people on the ground. Diesel, the reason why you use diesel fuel in a diesel engine, is very easy to ignite. Ethanol and methanol are harder, but at its heart, our technology is as simple as if you get it hot enough, anything burns. So we basically take that standard compression process, make it hotter so that you can still spray a hard to ignite fuel in and you run the diesel cycle.
So you're focusing on diesel engines because of their prevalence as engines that humans use. What kinds of fuels are alternative to diesel fuels that would produce lower emissions? And does ClearFlame have anything to do with innovating those, or it's just focused, you guys are just focused on the engine hardware?
It's a bit of both. We are focusing on making the question itself you're asking less restrictive. So in the absence of ClearFlame, what types of lower carbon fuels work in a diesel engine? Well, the answer to that is you have to figure out some way to make a synthetic or bio-based renewable something molecule that looks like diesel. We have things like biodiesel today. We have things like renewable diesel today. You could synthesize diesel from renewable energy if you really wanted. But ClearFlame's vision is that that's an unnecessary constraint. As I mentioned earlier, the differences between the fuels, diesel tends to be the biggest and most complex molecules you see in a liquid fuel. So they're very hard to produce biologically or artificially. And so their feedstocks are limited. Their production capacity is limited, and they're expensive. ClearFlame, what we said is we want to be able to use any fuel in a diesel engine. We want to be fuel agnostic. And if you can do that, you don't constrain the fuel ecosystem to say, make me a fuel that works in my engine. It's a partnership. We're saying we're going to make an engine that will run on any fuel. And you, fuels folks, you innovate and try to figure out how to make a liquid fuel that is as low carbon and cost effective as possible. And so the innovation that's happening today in fuels, I would say, is not because of ClearFlame, but because of ClearFlame, we will be able to innovate on fuels in a much more end-user focused manner, focus on scale and economics and carbon intensity, not chemical properties, because that's not the end goal, it's a means.
As BJ mentions, different types of fuel, from gasoline to diesel to biodiesel, can have different emissions profiles and therefore environmental impacts, depending on the makeup of the fuel and how it is burned. Here's Matt from Neste on the emissions associated with diesel combustion.
So all combustion has kind of the same emissions components, just at different levels. A big one back in the 70s was sulfur dioxide, SOx, right? Because that's what led to acid rain. Mm-hmm. So the fuel got cleaned up and you really cut down the sulfur emissions from engines, which helped a lot. There's particulate matter, which most people see a diesel engine, like an older one, that's the black soot coming out of the tailpipe, right? Gasoline's not going to make nearly as much of the particulate matter as a diesel might. There's NOx, or oxides of nitrogen. That's a really big component that people are talking about today because it's right there at the tailpipe. It can affect the local environment, right? But with current, on a gasoline side, you have your catalytic converters. And on the diesel side, you have selective catalytic reduction, another component that reduces NOx.
For some additional context, both NOx and particulate matter generated in the combustion of fuels from diesel to natural gas can pose serious threats to human health. NOx and particulate matter have been associated with increased risks of asthma and lung cancer. NOx gases also contribute to both acid rain and climate change. Wonderful stuff. Anyway, here's Matt again.
The latest generation of diesel engines and gasoline engines are incredibly clean. I mean, a diesel engine now compared to 15 years ago, the NOx and the PM, the particulate matter, are both down 98, 99% from where they used to be.
Interesting. So those are some of the local air pollutants associated with diesel fuel. Now, I'd love to talk about some of the climate impacts. When any carbon-based fuel like diesel is burned, it releases greenhouse gases. So why do we even use the word renewable in the term renewable diesel?
Sure. So think about the water cycle, right? You have water that goes clouds and then it rains and then it evaporates and goes back into the clouds and it's all right there. That's what we're doing, but with carbon. Mm-hmm. So rather, the petroleum industry is taking carbon that's been sequestered underground for hundreds of millions of years. And when we combust that and use the energy, we're putting more carbon into the atmosphere. And an analogy I use sometimes is think of it like a sponge, right? You can only fill a sponge so much, and then bad things can happen. Whereas like the carbon cycle analogy there, we're using biogenic carbon. So we're taking carbon that has been above ground recently, whether it's in plants or animals or other stuff, taking that waste, pulling that carbon out, and putting it back into the atmosphere. So we're wringing out the sponge and refilling it and wringing it out and refilling it rather than trying to pump more into it.
Fuels derived from organic matter are broadly referred to as biogenic fuels or biofuels. The emissions attributed to these fuels over their production and consumption are referred to as life cycle emissions. According to EPA estimates, life cycle emissions for renewable diesel are typically less than fossil diesel, but are still greater than zero. But as BJ described earlier in our conversation, these emissions estimates vary significantly based on how the fuel is made and what it is made from. For example, if hydrogen is used to create renewable diesel, and the hydrogen is made using fossil fuels, which is typically the case, it is much more dirty than renewable diesel made by green hydrogen. That's why Clearflame is retrofitting the diesel engine to accept cleaner fuels. Neste is one of those companies innovating to create cleaner fuels. To help us better understand the feedstocks that Neste uses, here's President of Neste United States, Chris Cooper.
Neste has made a concerted effort to specifically develop this production out of waste oils and residues. And so those would be in the form of used cooking oils, animal fats, tallows, right? The yellows, brown greases. Now, these may sound like technical terms, but this is the waste, right, that goes out of the back of our food preparation and or our restaurants after our French fries, donuts, or other products are produced. So what we call these are wastes and residues. Neste is not competing with food or feed for the purpose of creating energy. We use many different raw materials, about over 10 different raw materials that make our renewable products. A small portion of that residues come from the palm industry. In the early days, our industry was based on easy access to products such as palm oils. And again, the residues left behind as a result of the large palm industry. But it's important to understand the difference between palm oil and what we call PFAD, or palm fatty acid distillate. And the PFAD is the processing residue from the refining of food grade palm. And so again, it's a waste oil, a residue. By 2023, Neste plans on completely stopping its use of palm oil in the supply chain. We'll continue to use the waste streams derived from it because there certainly is value. And it's important to realize that these all fit into this waste and residue category. But our view is simple. As a company, we can only use feedstocks that can be sourced in a way that protects human rights.
And I want to, palm oil production has been identified, one of the greatest threats to the remaining rainforests on Earth today. And obviously any price that you put on kind of any component of that value chain, whether it's the primary component or downstream component, buttresses the market for that oil. So it's supportive, whether, directly or indirectly, of the activity that we're talking about. And so I'm wondering to what degree that impacts Neste's strategy.
Deforestation is hugely important to us. And we have a very strict supplier code of conduct. And we want to know what is the effect that they're having or have had in this space of deforestation. So it's important us to pay attention to that as we continue in the use of palm or its derivatives. This is a product that's in production, not for the human consumption, nor is it a product that we believe is driving deforestation as far as we're able to participate. What Neste believes it's done is led in this space of creating transparency and helping the rest of the world see where it can appropriately be used and properly be used. And when it becomes inappropriate, we're certainly compliant to 100% and want to find that we're working together with the industry to provide a proper product to the market.
The US EPA has identified that the amount of waste cooking oil available could be a limiting factor in scaling up renewable diesel. As other companies in the energy space start to create their own renewable fuels, is the amount of feedstock a problem?
We do believe that this energy transformation can depend on these feedstocks. But that's today. As we continue to expand the conversion of renewables into our energy stream, we must realize technology is going to play a huge role, even in this space. So today, where we're using waste oils and residues, we need to be continuing in our efforts as we have in the development of lignocellulosics. And that's really the conversion or the ability to take forestry waste and agriculture waste to convert to these types of renewable products and feedstocks, as well as algae. And algae, we found through our technology groups that we have a tremendous opportunity as we develop in this space to convert algae to energy, as well as power to liquids, which is a pretty exciting technology using green hydrogen and merging with CO2 in a pretty amazing way.
Now we'd like to transition back to our conversation with Matt to learn more about the developing markets for renewable diesel.
Here in the U.S., it's the West Coast, basically, because of the carbon programs that make it more beneficial for us. So California has their low carbon fuel standard, Oregon has their clean fuels program, things like that. And we're kind of keeping an eye on the rest of the country as their legislation changes. The fuel we make in places that have those carbon markets, we can go in and sell near parity with our fossil competitor, right? We can sell close to a fossil diesel price with fluctuations based on logistics and things. In California, for example, if someone were to bring fuel into the state, there's a mandated GHG reduction year over year that you have to be below, right? If you're below the line, you generate credits. If you're above the line, your deficit credits, you have to buy them from someone like Neste. Our fuel, feedstock-wise, can be much more expensive than fossil, or not. We don't track together. We fluctuate a bunch. But to make up for some of that increased cost on feedstock aggregation and everything else, we need to be in the markets that have those credits. That's why it's advantageous to go there and not somewhere else, because one, transport out of California off the West Coast would cost extra money, but two, we'd be giving up the credit value that helps us offset production cost.
So Matt, could you talk about the sort of the customer profiles? Where is it used, and how does it differ in terms of end use from traditional diesel or biodiesel?
Sure. Renewable diesel can be used anywhere fossil diesel is used. It meets that same spec, right? So there's no regulatory hurdles to get over. You don't have to change your storage or anything like that, any hardware. In a vehicle, there are some actual tangible benefits for a fleet owner as well. Whether it's the fact that the chemistry of the fuel means it doesn't attract water, which can be an issue for diesel fuel. The combustion itself produces less byproducts, so you can extend your oil change intervals. A fleet owner will definitely not have as many issues with the diesel particulate filter, which is one of those exhaust after treatment systems that helps minimize emissions. Like, those can be giant headaches for fleet managers. We have one customer on the West Coast. They've told us that over the past 18 months, they've saved over $20,000, and they actually put it down to dollars and cents. They save 2 cents per mile just because they're extending those oil change intervals. They're reducing maintenance and downtime by using a cleaner fuel that's putting less deposits in their engines, less deposits in those exhaust systems. 2 cents per mile may not sound like a lot, but when you start running a big fleet and running a lot of gallons, it's definitely a game changer compared to how things used to be.
For those of you who've listened to our episode on electric trucking, Are Electric Trucks the Answer? You may recall that electric trucks could also have huge cost savings for fleet owners. Along with their renewable diesel, Neste also produces sustainable fuels targeting other difficult to decarbonize sectors like marine shipping and aviation. Here's Chris Cooper on some of those efforts.
Renewable diesel is the most mature market that exists today around the world, and so we produce and sell the most of it worldwide. But some of the neat innovations exist in aviation, where sustainable aviation fuel, or SAF as it's known by the airline industry or aviation industry, it's a rapidly growing opportunity, and we're finding a home for every gallon of SAF we produce. We also find that the airlines, whether the national and or again the global carriers, were quick to adopt sustainable aviation fuel. So the name of the airlines is long. We found that the segments within the airlines as well, from the passenger airlines that you know and use, the cargo airlines that we hear about that move our cargo in and out of the countries, they have been able to access SAF in a meaningful way now through Neste. And again, the business aviation. We have locations where we've partnered with companies, Signature Flight Support, who's the world's largest service provider to the business aviation sector. They're the largest consumer and distributor of our SAF worldwide. Marine fuels, also very exciting growth space. Again, we know that the effect of just a small number of these vessels that travel our oceans have a huge impact. And so if Neste can participate through the conversion of its conventional facilities and refineries to produce these renewable marine fuels, we're going to be excited to be strongly driving and participating in that market. So I guess I'd like to characterize that as the hardest to abate. We see that cars can take batteries. We see that heavy trucks can take batteries, but as Neste continues to work in this liquid fuel space, we want to be sure we're helping those that are disadvantaged without the ease of conversion.
As the energy transition shifts into full gear, the rise of the biofuel industry can give workers in the fossil fuel industry the opportunity to use their knowledge and skills to help develop this new, cleaner technology. Here's Matt from Neste on how the company has benefited from this dynamic.
The opportunities in the renewable space are fairly endless, just because of all the growth. We have quite a few people in our company, whether it's on the commercial side, anywhere from a salesperson all the way to a vice president, that have come from fossil fuel companies. Even over in Europe, a lot of our researchers are coming from those spaces because they're familiar with refining processes and chemistry and chemical engineering and things like that. Our company, we're probably 20% technical R&D development type people. And that knowledge is not specific to the fossil industry, right? We're building hydrocarbons. And if we're building the same stuff, all the same knowledge can apply anywhere. So yeah, I think there's a lot of opportunity if people wanted to make that jump.
Both Matt and Chris worked with traditional fossil fuels before coming over to Neste to work on renewable fuels. They're part of a larger trend of workers leaving the fossil fuel industry, which is simultaneously struggling to recruit young people, in part due to climate concerns. Here's Matt again.
I think a lot more people are starting to see the writing on the wall and voluntarily making the move. So I think that industry may have a talent issue. It was always a joke, but there was the crash in the 80s for the oil industry, and there was a huge generational gap there. You had the old guys and the young guys, but nothing in between, really. If I were on that side of the fence now, I'd be scared that the young side just may not fill the gaps anymore.
I was curious to understand more about how the larger energy industry, beyond those folks who are producing renewable fuels, are responding to Neste's moves. Would you characterize it as observing from the sidelines or mad scramble to catch up?
I think if I had to put my thought on it, I would say somewhere in between, because they do have their current industry, their current supply that they have to meet, right? So they can't just turn that off and get rid of their current fossil-based production. Mm-hmm. But knowing the way the world is going, whether it's legislative or just pressure from ESG or other things, everyone will end up having to go green. But you do see a lot more of the oil majors getting in. Chevron recently purchased one of our competitors. Marathon Petroleum, with the joint venture with us, is getting into it. Mm-hmm. Shell over in Europe, they have their technology they're using. ExxonMobil has developed their own renewable diesel production technology. Eni, there's a lot of majors out there that they may not be investing large percentages of their wallet into it, but it's definitely not something they can ignore.
That was Matt Luke and Chris Cooper of Neste, along with BJ Johnson of Clearflame, discussing the fast-growing biofuel industry. Biofuels like renewable diesel have significant potential to help decarbonize some of the hardest to abate sectors, thanks to their ability to easily replace traditional fuels. Responsible development of those biofuels will be necessary to realize their full decarbonization potential, while also ensuring they are not used to perpetuate fossil fuel reliance. That's it for this episode of the Climate Now podcast. For more episodes, videos, or to sign up for our newsletter, please visit us at climatenow.com. We hope you'll join us for our next conversation. Climate Now is made possible in part by our science partners like the Livermore Lab Foundation. The Livermore Lab Foundation supports climate research and carbon cleanup initiatives at the Lawrence Livermore National Lab, which is a Department of Energy applied science and research facility. More information on the Foundation's climate work can be found at livermorelabfoundation.org.